So let us begin with the next chapter, oscillations. Now what are oscillations? So oscillation is a to and fro motion. To and fro meaning, so a body, it moves towards some point and away from that point, you can say. So first let's define the simple harmonic motion. Simple harmonic motion means oscillations in short, okay? And why it is called a simple harmonic and all, we'll come to that later. Okay, so what is a simple harmonic motion? The definition is, it is a to and fro motion of a particle about some mean position in which the force is always directed towards the mean position and is directly proportional to the displacement. Okay, so what does the simple harmonic motion mean? It means simple harmonic motion means oscillation only. Okay, and definition is that it is a to and fro motion. So it moves to and fro like this about some mean position. It has got some mean position, okay, and in this kind of motion the force is always directed towards the mean position and is directly proportional to the displacement. Okay, so force is directly proportional to the displacement, right, and it's directed towards the mean position. For an example, suppose you have the spring. One end of the spring is connected to rigid support, other end is connected to this block, and suppose it is kept on some table. Okay, you stretch that block and release it, and suppose the table is smooth, right, perfectly smooth, that means there is no friction. Then what will happen? So when you pull that block, the spring gets stretched, okay, and therefore what will happen? There will be a restoring force generated in the spring which will be directed towards the mean position. Okay, that force will be directed in opposite direction of displacement. More you stretch the spring, more will be that restoring force, right? So here the force would be directly proportional to the displacement, but it is opposite to displacement. That means if you stretch it, the force will be directed like this. If you compress the spring, then force will be directed like this, right? So this force is always directed towards the mean position, right, and is directly proportional to the displacement. So the motion of this spring mass system or spring block system, it defines simple harmonic motion. Okay, it is an example of simple harmonic motion, right? So simple harmonic motion is, it is a to and fro motion of a particle about some mean position in which the force is always directed towards the mean position and it's directly proportional to the displacement. Okay, then you have this pendulum. Suppose this is another example. So what is a pendulum? It is some mass tied to a string and you give some that string is hung from a rigid support, right, and then you give some displacement to it and then it oscillates like this. Okay, so this is another example of a simple harmonic motion. Okay, so this is linear simple harmonic motion and this one is angular simple harmonic motion, because here the angle with respect to vertical, it changes periodically, right? Okay, so this is a periodic motion. What is a periodic motion? A motion which repeats itself in equal intervals of time, right? Periodic motion is the motion which repeats itself in equal intervals of time. Okay, this thing is clear, everyone? Right, this is very simple. Okay, so after that, now what we are going to do is, we are going to find out the acceleration, velocity and displacement of any particle which is performing simple harmonic motion, or you can say the oscillation, right? So now we'll take an example of spring mass system. So this is a spring which is connected to this rigid support. Okay, this rigid support, and other end is connected to this block. You stretch the block and you release it. Then the spring follows this law which we just saw, that force is directly proportional to what? Displacement, and it is directed opposite to the displacement. Now this law is called as Hooke's law. Okay, So it was Robert Hooke who discovered this law. So this law is known as Hooke's law. Okay. So f is proportional to minus x. Then you remove that proportionality sign and put an equality sign. So a constant will come, constant will enter, and in different systems the constant will be different. So in this case, this is the spring constant. Okay. In case of a spring mass system, it is a spring constant. So spring constant is suppose k, right? So here you get f is equal to minus of kx, and then you write force is equal to mass times acceleration. So you get mass times acceleration is minus kx, and then acceleration can be written as dv by dt, okay, rate of change of velocity with respect to time. Then the velocity can be written as dx by dt, okay, rate of change of position with respect to time, okay. So if you replace this velocity by dx by dt, then it is d by dt of dx by dt, acceleration is d by dt of dx by dt, so it can be written as what, d2x by dt square, and this thing is called as what, double derivative of x with respect to time. We are taking two times derivative of a derivative, okay. So of course we have seen this earlier also when we saw motion, okay, we have seen double derivatives, okay. So then this thing is mass multiplied by d2x by dt square is equal to minus kx, and then you can move m on the other side. You can write d2x by dt square is equal to minus k upon m into x, because this m will go into the denominator, and this thing is called as the differential equation of linear SHM, okay. So this equation is known as equation which contains derivatives, and this equation is known as a differential equation. So this is equation which describes the motion of simple harmonic motion. It describes simple harmonic motion. So this is known as differential equation of linear SHM, okay. This one, or you can move this whole term on left hand side, so you can write d2x by dt square plus k by m times x is equal to 0. So this is the differential equation of linear SHM. So this thing is clear, everyone? All right. So there can be some question based upon this thing also, that what is differential equation of linear SHM, okay, and they can give different examples, I mean different options. So you can choose, I mean you need to choose the correct option out of those, okay. All right. After that what we are going to do is we are going to solve this differential equation to find out the acceleration, velocity, and the displacement, or let's say position, of this object or a particle performing simple harmonic motion. So what we do here is we substitute k by m equals to omega square, okay. We substitute k by m equals to omega square, and reason for that we'll see later, okay. We just write it as k by m as omega square. All right. So if we do that substitution, then our differential equation becomes d2x by dt square plus omega square x is equal to 0, okay, and it will, omega will turn out to be the angular frequency of linear SHM, okay. It will turn out to be equal to what, angular frequency of linear SHM. So omega, then if it is angular frequency, it can be written as 2 pi times linear frequency, we know this thing, right. Omega is equal to 2 pi divided by t, or it can be written as 1 by t can be written as what, n. So we know this thing, right, and n would be the frequency. So if omega is equal to square root of k by m, then omega is 2 pi n, so 2 pi n is equal to root of k by m. So from that you get n is equal to 1 upon 2 pi square root of k by m, and if you want time period, it's just reciprocal of that. So time period is just equal to what, 2 pi square root of m by k, right. So for now let's believe that this is angular frequency, and if angular frequency is equal to square root of k by m, then frequency would be equal to what, 1 upon 2 pi root of k by m, and the time period would be equal to 2 pi square root of m by k, okay. This thing is clear, everyone? Right, okay, good. So then now So Hooke's law says that force is equal to minus of kx, okay, and force is mass times acceleration, that is equal to minus kx. So if you move mass on the other side, you get acceleration is equal to minus of k by m into x, right? Acceleration is equal to minus of k by m times x. So you can say acceleration in linear SHM is equal to minus of k by m into x. That's one formula. And you know what is k by m? So k by m is equal to omega square. So acceleration would be equal to what? Minus of omega square times x. Okay, acceleration is equal to minus of omega square times x, right? So you got formula for acceleration. After that, acceleration can be written as dv by dt, and that is equal to minus of omega square into x, because k by m we substitute as omega square, and then this dv by dt can be written as, see here the problem is you have three variables, okay. Now if you want to find out velocity, either you will have to find it out in terms of position, or you will need to find it out in terms of time, okay. So now suppose you want it in terms of position. So what will you do? You need to get rid of time. You can't have three variables in an equation, okay. There are three variables and there are only two sides to equation, okay. So if you want to relate one variable with another one, then you will need to get rid of the third variable. So you get rid of time here. How do you get rid of that? So for that you just multiply and divide by dx, okay. So multiply and divide by dx. So then what happens is you have dx by this dt, and then so you have multiplied by dx and you divide by dx. So dx by dt, you know it is v, okay. So then you have v times dv by dx is equal to this right hand side, and you move dx on the other side. So you get v dv is equal to minus of omega square x dx, okay. v dv is equal to minus of omega square x dx, right? And now you can integrate this. So then you integrate this. So integrating this, you get integration of v dv is equal to omega square is a constant, because k is spring constant and m is mass of the block, both are constants. So omega square is a constant. You move it outside of the integration, then what is left is the integration of x dx, right? And then you integrate it. So integration of v raised to 1 dv is v square by 2, right? Remember the formula. If you have v raised to n, its integral would be v raised to n plus 1 divided by n plus 1. So here n is equal to 1, so it is v raised to 1 plus 1 divided by 1 plus 1, that means 2, right? So v square by 2 is equal to minus of integration of this thing, x is equal to x square by 2, and then because this is indefinite integration, we put a constant here, right? So constant would be c, some constant c. So then now see your object, that means the block in the spring mass system, a spring block system, it moves like this, okay. The block moves like this. So what happens is suppose it goes from here to here, okay. So let's say it goes from this position to this position, then it will stop there for a moment and it will come back. So at extreme positions, suppose the block is moving from this position to this position, these are the extreme positions. So when the block goes here, it goes like this, okay, and it stops there, then it comes back. So what is the speed at the extreme position? What's the velocity? Velocity at extreme position would be equal to 0, right? Velocity at extreme position would be equal to 0, and then you substitute that for x equal to plus or minus a, not just for the plus or minus a, okay, at x equal to plus or minus a. These are extreme positions, right? A is the extreme position, plus or minus a is the extreme position. So for x equal to plus or minus a, v is equal to 0. You put that over here, right? So then what do you get? X is equal to plus or minus a, so its square is just a square, and the speed is equal to 0. So 0 is equal to minus omega square a square by 2 plus c, and then you move this thing on other side and you get c is equal to omega square a square divided by 2, right? So you got c, again you put that in this equation, equation number 4, and when you put that you get v square by 2 minus omega square x square by 2 plus omega square a square by 2, right? So v square by 2 is equal to this thing, and then you cancel out 2 from this equation, okay, and you get v square is equal to, you can take omega square common, omega square it's taken common, then what's left is the a square minus x square, okay, what is left is a square minus x square, and then you take square root of that. So square root of that would be plus or minus omega multiplied by square root of a square minus x square, okay. So now this is the equation for the velocity in terms of position, right? Velocity is equal to plus or minus omega square root of a square minus x square, okay. And what does this plus or minus mean? So whether the particle is moving towards right or towards left, okay, whether it is moving towards right or towards left at any position. See, at any position, suppose the particle is moving towards left, so at this position, this is suppose x, so at this position the particle is moving left, towards left, then you will have negative sign, then the particle moves like this and it comes back, so at the same position again after some time it will be moving towards right, okay. So at any position the particle can have two velocities, one towards left, one towards right, okay. So that plus and minus sign takes care of that. All right, so this is the equation for the velocity, v is equal to plus or minus omega square root of a square minus x square, and then you write v is equal to dx by dt, so you get dx by dt is equal to omega times square root of a square minus x square, and you move this thing on this side and dt on the other side to find out the relation between position and time, okay. So then you have dx divided by root of a square minus x square is equal to omega times dt, you integrate this, so again you move omega outside, and then integration of dt just t, okay, integration of this thing, integration of 1 upon square root of a square minus x square is sine inverse of x by a, okay, this integration is sine inverse of x upon a, and that is equal to omega times integration of dt is t, but again this is indefinite integration, so you substitute a constant over here, okay, that constant is suppose phi, okay, suppose that constant is equal to phi, right. So you get sine inverse of x by a is omega t plus phi, and then so therefore x by a would be sine of this thing, right, sine of omega t plus phi, and then you move a on other side and you get x is equal to a sine of omega t plus phi, right, a sine of omega t plus phi, okay. So this is equation for x, and now see here depending upon the value of phi, so at t equal to 0 phi will have some value, whether it's 0, okay, whether it's 90 degrees, whether it's 180 degrees, something like that, okay, I mean any value of phi. So the particle's position will change with respect to time, okay, and suppose phi is equal to 0, then the equation would be just a sine of omega t. So this phi is known as starting phase, right, this is known as starting phase. What is phase? Total phase of the particle is this term inside the argument, sorry, this term inside the bracket, which is known as argument also, okay. So sine of omega t plus phi, you have the sine function, so omega t plus phi is known as phase and phi is known as starting phase, right, this is just a name, okay, and this phase defines state of the particle. State means the position and the velocity of particle, okay. Is this thing clear to everyone? Right, good. All right, and then sine and cosine are called as harmonic functions. Okay, and we solved for the motion of this particle which is moving to and fro. Okay, which is moving to and fro like this. Okay, this particle is moving between these two positions, minus a and plus a, to and fro, and here the force is directly proportional to what? The displacement. It's directed away from displacement, meaning in opposite direction of displacement. And when we solve for the motion of this particle, we get that its position is function of what? I mean, position is sine or cosine of something, right? Something is omega t plus phi. Okay, and sine and cosine are known as the harmonic functions. That's why this motion is known as simple harmonic motion. So now suppose our particle starts at the extreme position, then what would be its equation of motion? And if particle starts at the mean position, what would be its equation of motion? So see, when t is equal to 0, particle is starting from extreme position. That means x would be equal to what? A. So here we are considering it's starting from the positive extreme position. So you have stretched the spring and you release it, right? So you start observing the motion. So that time is t equal to 0. Then the object or particle, it is at extreme position. So at t equal to 0, the particle is at extreme position. So you substitute x is equal to what? A. So you get a is equal to a sine of omega t plus phi, and t is equal to 0. So this term becomes 0. So you have a equals to a sine of phi only, right? Then a gets cancelled out. That means what remains is sine phi is equal to 1. If sine phi is equal to 1 means phi is equal to what? Pi by 2, right? Because we know sine of pi by 2 is equal to 1. Okay, so phi is equal to pi by 2. So then you substitute that here. So what do you get? X is equal to a sine of omega t plus pi by 2. And what is sine of omega t plus pi by 2 or sine of pi by 2 plus any angle? It is cos of that angle, right? So therefore you get x is equal to what? A cos of omega t. Okay, therefore you get x is equal to a cos of omega t. So if particle starts from the extreme position, its equation of motion would be a cos of omega t. And then if it starts from negative extreme position, then you would just take minus a cos of omega t, right? This thing is clear? Everyone? Okay, good. And if particle starts at the mean position, then what will you take? At t equal to 0, x is equal to 0, right? So you substitute that here. So at t equal to 0, x is 0. So t is 0 means omega t is 0. So 0 is equal to a sine of phi. 0 is equal to a sine phi. That means sine phi is equal to 0. So phi is equal to 0. Again you substitute that back in the equation. So what do you get? X is equal to a sine of omega t plus 0 means omega t only. So x is equal to a sine omega t, right? So if particle starts from the mean position, its equation of motion would be x equal to a sine of omega t. So particle starts at mean position, equation would be what? Equation for the position would be a sine omega t. Particle starts at the extreme position, it would be equal to a cos of omega t. Okay, and for some other position, this is general equation. If particle starts at any other position, that a sine of omega t plus phi, then phi will have some different value apart from 0 and 90 degrees. Okay, so in this equation, a is known as the amplitude. Okay, the maximum displacement from mean position is known as amplitude, and this thing omega t plus phi is the angle. Okay, this thing is known as phase, right? So this is known as phase, and in this thing, when t is equal to 0, phase is phi. So phi is known as starting phase. Okay. Okay. So from equation 2, we have a is equal to minus of k by m times x. So this is one equation for acceleration. Then you have k by m equals to omega square. So you get a is equal to minus of omega square x. So this is another equation for the acceleration, right? And now if you want to find out the maximum value of acceleration, just substitute x is equal to plus or minus a, and you will get what? The maximum value of acceleration at two extreme positions would be equal to omega square a, right? The magnitude of that is equal to omega square a, right? This is maximum value of acceleration. Then now where would be the velocity maximum? So we have seen that acceleration would be maximum either at plus a or minus a, okay, because force at that position would be maximum. Force is directly proportional to what? Displacement, but it is directed opposite to the displacement. So force is equal to minus kx, right? It will be maximum when x is maximum, the magnitude of force is maximum when x is maximum. So there only the acceleration would be maximum at plus a or minus a, okay. Then where would be the velocity maximum? So velocity is maximum at the mean position, okay. Why is it so? So now we can understand that from the formula. So at x equal to 0, the velocity would be maximum, because the formula for velocity is v is equal to plus minus omega square root of a square minus x square, okay. So when you put x equal to 0, this term will become maximum, that is v is equal to plus or minus a times omega, okay, plus or minus a times omega. Now you can easily understand why it would be maximum at the mean position. The reason is, see, suppose it goes to this, suppose the particle is stretched or the spring is stretched like this, okay, at this extreme position, then what will happen? The spring will pull pull that block towards the mean position. So block is being pulled, that means it is accelerating, and the acceleration will keep on continuing till the time the block reaches the mean position. Once it reaches the mean position, the acceleration will become 0 at that position, okay. So the velocity is increasing and increasing till the time the object reaches the mean position. Then that at that position the velocity becomes maximum, right? I'm sorry, this thing is clear? Why is the velocity maximum at the mean position? Okay, so at mean position the velocity is maximum. Then what will happen? Once the object uh, crosses the mean position, okay, at mean position velocity is maximum. Once the object crosses the mean position, then the displacement is in other direction. So once it crosses the mean position, displacement is in other direction. So again the spring will pull it in this direction. So what will happen to the velocity? So acceleration becomes negative. Now object is moving like this, but the acceleration would be negative because spring would pull, okay. Once the displacement is towards left, let's say the acceleration would be towards right. So spring will pull that object, and that's why its velocity will go on decreasing, and at some point it becomes 0. That means at the negative extreme position it will become 0, okay. And again at that position the acceleration would be maximum, okay, but towards the mean position. So the object is pulled at the extreme position, its velocity becomes 0. Again it is pulled towards the mean position, so its velocity goes on increasing and increasing till the time it reaches the mean position, okay. And again what will happen? Once it reaches mean position, the force on it will become 0, because force is directly proportional to the displacement. Again it crosses the mean position, then what will happen? So it reaches mean position with maximum velocity, it crosses the mean position, then the acceleration will act in the opposite direction, and therefore its velocity will go on decreasing. Now what we have done is, we have written expression for velocity in terms of position. Now suppose you take position of a particle x is equal to a sine of omega t plus phi, and you want to express the velocity in terms of time. Then what will you do? Just take derivative of that position. So derivative of position gives you velocity. So velocity is dx by dt. Then you get v is equal to what? So if you take derivative of this thing, sine of omega t plus phi, its derivative is what? cos of omega t plus phi multiplied by omega, right? So we have seen this several times. So here we are making use of chain rule. Okay, derivative of some a times t, sorry, derivative of sine of a times t would be what? So derivative of sine of this bracket is equal to what? Cos of bracket multiplied by derivative of bracket with respect to t. Okay, that's the chain rule, right? So by using chain rule, what do you get? You get speed is equal to a omega multiplied by cos of omega t plus phi. Okay, does everybody understand this? Remember the chain rule? Alright. So the position of particle is suppose a sine of omega t plus phi, then velocity is dx by dt, right? Velocity is dx by dt. So taking derivative of this, we get a times derivative of sine omega t plus phi is cos of omega t plus phi multiplied by omega by chain rule, right? And then you have a times omega multiplied by cos of omega t plus phi can be written as what? Sine of omega t plus phi plus pi by 2, right? This thing can be written as cos, can be written as cos of an angle can be written as what? Sine of omega t plus pi by 2. Okay, sine of that angle plus pi by 2. Yes, no? Okay, angle is omega t plus phi. Suppose this thing is theta. So cos theta is sine of pi by 2 plus theta, right? Yes, no? Or actually, I guess sine of pi by 2 plus theta is equal to what? Sine pi by 2 cos theta plus cos pi by 2 sine theta, right? Cos pi by 2 is 0. So the second term is 0. Sine pi by 2 is 1. That's why what do we have here? Cos of theta is equal to sine of pi by 2 plus theta. Okay. So sine of pi by 2 plus this angle omega t plus phi is cos of this angle, right? This thing is clear? Yes, no? Okay. All right. So see, if phase of position is omega t plus phi, what is phase of velocity? It is omega t plus pi by 2. That means there is a phase difference between the velocity and position. How much is the phase difference? Phase difference is pi by 2, right? Phase difference is pi by 2. Then you find acceleration. So acceleration is what? dv by dt, okay, which can be written as minus of a omega square times sine of omega t plus phi, because if you take dv by dt, so v is a omega cos of omega t plus phi, again take its derivative. So derivative of cos of something is minus sine of that thing, okay, but that thing is this bracket, so you need to multiply by the derivative of the bracket also, okay. So derivative of this thing is minus a times omega multiplied by derivative of this thing is sine omega t plus phi multiplied by omega, so that omega comes here, a omega times omega, okay. So the acceleration is minus a omega square sine of omega t plus phi, and this thing can be written as what? This negative sign you can absorb inside the bracket, so this thing can be written as sine of omega t plus phi plus pi, because once again sine of pi plus theta or theta plus pi is sine theta cos phi plus cos theta sine pi, okay, and sine pi is 0, right, and cos of pi is minus 1, so it is minus sine theta. So sine of theta plus pi is minus sine theta, or you can say minus of sine theta is sine of theta plus pi. So here you have minus of sine this angle is theta suppose, then it is sine of theta, which is this angle, plus pi, right, theta plus pi, okay. So theta is omega t plus pi. So therefore acceleration is a omega square sine of omega t plus pi plus pi. So if you compare that with the position, So here the phase is omega t plus pi, here the phase is omega t plus pi plus pi. So the phase difference is equal to pi, right? The phase difference in position and acceleration is pi. So between position and velocity, phase difference is pi by 2. Between velocity and acceleration, phase difference would be pi by 2. And between position and acceleration, phase difference is pi. Okay, is this thing clear, everyone? Right. Okay. All right, good. So then now how will the graph of SHM look like? So if you plot position, see, you take this equation. Suppose the particle is starting from the extreme position, then its equation is a cos of omega t, right? For particle starting from extreme position, the equation of position is a cos of omega t. Then equation for velocity is, if you take derivative of this thing, you get minus of a omega sine omega t, and equation for acceleration would be minus a omega square multiplied by cos of omega t. That is, you take derivative of this thing again. Okay, and this thing can be written as, of course, a is equal to minus of omega square x, right? So then you take some points. For an example, so at t equals to capital T by 4. Now what is this capital T? Capital T is the time period. Okay, so omega t can be written as what? Omega we have written as 2 pi by t. Okay, omega can be written as 2 pi by t, right? So then t is suppose the time period. Okay, then omega t will be 2 pi by t times t. Okay, and then at t equals to t by 4, you put that here, you get 2 pi by t multiplied by t by 4, so that t will get cancelled. What would be the phase? So it is 2 pi divided by 4, means it is pi by 2, right? It is pi by 2. Okay, so similarly you find at t equals to t by 2, what would be the phase? So at t equals to t by 2, put t by 2 here, tt would get cancelled. Okay, this 2 will get cancelled, and phase would be equal to pi. Okay, phase would be equal to pi, right? At t equals to 3t by 4, similarly the phase would be equal to what? You substitute that and it will be equal to 3 pi by 2. At t equals to capital T, the phase would be equal to 2 pi, right? And you substitute that. So at t equals to 0, the phase is of course 0, cos 0 is 1. So what would be x? X is equal to a, because cos 0 is equal to 1, right? So x is a at t equal to 0. Then take t by 4. So at t by 4, we have seen the phase is what? Pi by 2. So put pi by 2 over here. So cos of pi by 2 is 0. Therefore it is a times 0, and therefore you get this point at t equals to t by 4. Okay, position would be 0. That means mean position. Again, you take 3t by what? T equals to t by 2, right? T equals to t by 2. So at t by 2, the phase becomes what? Minus pi. We have seen this. Sorry, what did I say? Minus pi. So phase becomes pi, and the at t equals to t by 2, the phase becomes pi, right? So you substitute pi here. So cos pi is minus 1, and therefore you have a times minus 1 means minus a. So the position becomes what? Minus a at t by 2. Okay. Then similarly you plot at t equals to 3t by 4, what will happen? So at 3t by 4, the phase becomes 3 pi by 2. Okay, that is 270 degrees, and cos of 270 is also 0. So again you get this position. So this way you plot the graph. Okay, this way you plot the graph, right? And you get this cosine curve. Okay, then similarly what you do is you plot the curve for velocity, and the curve for velocity would look like this. Okay, curve for acceleration would be what? If curve for the position is like this, curve for acceleration would be like this. So here you need to understand suppose the curve for position is given, how will the curve for velocity look like? So if it is like this means that it is cos function, right, cos of omega t. Okay, then suppose this curve is given and there are 4 options for the curve or the graph of velocity, then what will you do? So if it starts from positive extreme position, then it means that this is a cos function. Take derivative of that, you get minus sign, so the velocity will be negative sine curve, right? So you know sine curve looks like this. Okay, sine curve looks like this. So what would be negative of that? So it will be just mirror image of that. So it will look like this. Okay, is this thing clear, everyone? Right? Good. And then identifying curve for acceleration is very simple, because acceleration is just minus omega square times x. So this is curve for position. Just take its mirror image. Okay, if position is plus a at what? X equal to 0, what will be the acceleration? Acceleration would be minus of omega square times a, right? Minus of omega square times a at the starting point. Okay, so if position is above the time axis, then acceleration would be below the time axis, right? So the curve for acceleration would be like this. So this thing is clear. If you write omega is equal to 2 pi by t, right, and you take different values of that t, different values of t equal to 0, t equals to what, t by 4, t equals to t by, okay. So what we are doing here is we are writing omega equals to 2 pi by t, then we are substituting different values of t, that is t I'm sorry. Okay, so what we are doing here is we are taking different we are writing omega equals to 2 pi by t, and then we are writing different values of t. We are taking different values of t equal to 0, t equal to t by 4, then t by 2, etc., and 3t by 4, so on and so forth. Then what we get is we get this graph. Okay, and this graph will repeat itself after every t. What does that mean? That the t is what? The time period, right? Okay, the t is time period, and if t is time period, then what must be omega, which is 2 pi by t? So this must be angular frequency. Okay, because 1 upon time period is what? It's the frequency. So omega can be written as 2 pi times n. N is 1 by t. Okay, and then from that you get omega is what? The angular frequency. Is this thing clear? So we wrote at the beginning that omega is angular frequency, but we can only understand that once we see these graphs, because these graphs for position, velocity and acceleration, they will repeat after every t, right? They will repeat after every t. So that means that t is the time period. Okay, so at the beginning you don't know that t is time period or whether omega is angular frequency. You just substitute it. See, at the beginning k by m equals to omega square, we wrote k by m as omega square, right? So omega was just later. Okay, we solved equations using k by m equals to omega square. We got certain equations, then we plotted those graphs, and from those graphs we understand that if omega is equal to 2 pi by t, if we take that, then this motion repeats itself after every t. So this is a periodic motion, again, that we understand from the graph only, okay, or from this equation that we get at the last, that a what, x is equal to a sine of omega t plus something, or let's say just omega t. Okay, so this is sine or cos, these are periodic functions. Okay, and because you got the periodic function, means your motion is periodic. Then you find what's the period. Okay, what's the period? So period is t, suppose. So the sine of omega t can be written as sine of 2 pi by t times t, okay, then t would be the period. Okay, so at the beginning you don't know, when you solve this equation, at the start you don't know, that you are going to get sine or cosine function. So you have substituted k by m equals to omega square. Okay, but it turns out that it is the angular frequency. Okay, is this thing clear? Okay, so then let us try to solve some problems based upon these things. So the xt graph of particle performing simple harmonic motion is shown in the figure. So this is the xt graph. The acceleration of the particle at t equals to 2 seconds is, okay, tell me what is the acceleration of this particle at t equals to 2 seconds. So make use of acceleration is minus of omega square x, right? So omega can be written as what? The acceleration of particle at t equal to 2 seconds. So see, at t equal to 2 seconds, where is the particle? Particle is here. Okay, so at t equal to 2, what is x? X is equal to 1, and that is in meters, right? So then you can substitute acceleration is just equal to minus of omega square. But then what is omega? So to find out what is omega, you need to find out the time period, and here it seems that the time period is equal to what? 8 seconds. What is the time period here? 8 seconds. Okay, so t is equal to 8 seconds, and acceleration is equal to, okay, so t is equal to 8 seconds, acceleration is minus omega square, that means minus of 2 pi by t, and you have square of that, so that is equal to minus of 2 pi divided by 8 square. Okay, and this is 2 by 8 means 1 by 4, square of that would be 1 by 16, it is minus pi square by 16. Very simple, right? Meters per second square, that is the acceleration. So it is option D. Okay, this is simple, right, everyone? Okay, so this one was from NEET 2023, very simple question. Okay, let's see next one. Identify the function which represents a non-periodic motion. Okay, we want non-periodic motion here. So sine of omega t plus pi by 4, we know this is periodic. Sine of omega t, of course this is periodic, right? Then e raised to minus omega t, it is non-periodic. How? So if you just plot e raised to minus omega t, okay, so at the beginning, what will be its value at t equal to 0? Put substitute t equal to 0 here. So it will be e raised to 0. E raised to 0 is 1. Okay, so it starts at 1 at t equal to 0. Okay, so this is 1. And then as t increases, what will happen to this? This thing is e raised to minus of omega. Omega will have some value. Suppose t is equal to 1. So then it will be e raised to minus omega, or you can say it will be 1 upon e raised to omega. And if e is greater than 1, which it is, okay, it is 2 point something, 2.7 something, so you have 1 upon 2 raised to omega, means let's take 2 only, 2 raised to omega, right? Omega would be positive, so this thing would be less than 1. And as t increases, so t becomes 2, then it will be 1 upon what? E raised to 2 omega, it will be even lesser, okay, because denominator is increasing. So as t increases, this function would decrease, and it will keep on decreasing, it will never increase, right? So it will look something like this. So this is e raised to minus omega t, so this is not at all periodic. Okay, so answer is option B, right? Then finally, what's sine omega t plus cos omega t? Is it periodic? Not periodic. If this is not periodic, then all others must be periodic. So this is periodic, right? And we can understand it very easily. Okay, So how can you understand that? So see, you have some function, let's say sine of omega t plus pi by 2. Okay, it will be sine omega t, sine omega t, cos pi by 2. Okay, so here this thing is sine omega t plus cos omega t. Okay, so this is your sorry, this is sine omega t plus cos omega t. So here this one is periodic with period equal to 2 pi by t. This thing is also periodic with period equal to what? 2 pi by t. Oh, what did I say? Period equal to 2 pi by t. Okay, so sorry. See here you have sine of omega t and cos of omega t. This one is periodic. So omega is equal to 2 pi by t here. If you substitute omega equals to 2 pi by t here also. So this one has period t. This one also has period t. So then if you overlap the two functions, right? If you add the two periodic functions having same period, then the total will also have same period. Okay, this thing is clear. The addition will also have same period. Yes, no, right? So this one is periodic. Okay, so this one is simple. So here you have two SHMs, right, having same period, but they are 90 degree out of phase. Okay, sine and cos, they are 90 degree out of phase. If you add them, this is going to be a periodic function. Okay, all right, but we'll see addition of SHMs later. Okay, we'll see addition of SHM. So if you add two SHMs, the result would be SHM. Okay, we'll see that later. All right, let's see next one. The phase difference between the displacement and acceleration of a particle in a simple harmonic motion is. This is from NEET 2022. Okay, so this is, I guess this is not clear for you. It is from NEET 2023. In fact, sorry, NEET 2020. This is from NEET 2023 only. All right. So the phase difference between displacement and acceleration of particle in simple harmonic motion is. Tell me what's the answer? It's option D, right? So this question has been repeated many times. But since it came in NEET 2023, I don't know whether it will come in NEET 2024. Okay. But yeah, this is displacement and acceleration. They can say phase difference between displacement and velocity, or velocity and acceleration. That would be pi by 2, right? Let's see next one. The phase difference between the displacement and acceleration of particle in simple harmonic motion is. So NEET 2020. So they asked it again. 2020. Okay. Designed by NTA, of course. 2023 NTA. So they repeated the question. So it is pi, right? The phase difference between displacement and acceleration is pi. Let's see next one. The distance covered by a particle undergoing SHM in one time period is equal to. Tell me. Option D. Everyone. Distance covered. Total distance covered in one time period. So suppose your particle starts from minus A, it goes to plus A. Okay, then it comes back. So distance from here to here is A, here to here it is A, then it goes towards the other position, other extreme position, and it comes back. So this distance is also A plus A means 2A, 2A plus 2A, 4A. So distance covered in one time period is equal to 4A, right? This one is simplest question. Okay, yes, no? Okay, let's see next one. The displacement of a particle along x-axis is given by x is equal to a sine square omega t. The motion of the particle corresponds to simple harmonic motion of frequency omega by pi, simple harmonic motion of frequency 3 omega by 2 pi, non-simple harmonic motion, and a simple harmonic motion of frequency of omega by 2 pi. Okay, what would be the answer? It is sine square omega t. Is it simple harmonic? Not simple harmonic? Everyone, tell me. Okay, so now see, it might not seem simple harmonic, but let me explain. This is simple harmonic. Okay, so see how. So we know this thing that cos of, or 1 minus cos of 2 theta is equal to 2 sine square theta. Okay, we know this thing. So if you move that 2 on this side, what will you get? Sine square theta is equal to half of 1 minus cos of 2 theta, right? Now if you take that equation, x is equal to a sine square omega t. So your theta is omega t, right? So this thing can be written as half of 1 minus cos of 2 omega t. Okay, so it is a by 2 times 1 minus cos of 2 omega t, and this thing is equal to, x is equal to a by 2 minus a by 2 cos of 2 omega t. Now is this thing simple harmonic or not? This is simple harmonic. Okay, how? So see, you can just define some position x dash, x prime, it's equal to x minus x by a by 2. Okay, if you write x prime is equal to x minus a by 2, you move this a by 2 on other side. So the equation for x prime is just equal to what? Is equal to minus a by 2 cos of 2 omega t. Now tell me, this is simple harmonic or not? This is simple harmonic, right? Because it starts from, let's say, negative extreme, and then it oscillates with some frequency omega prime, angular frequency omega prime, which is equal to 2 times omega. Okay, so if x prime changes simple harmonically, if it oscillates simple harmonically, then the position x will also oscillate simple harmonically, because the difference between x prime and x is just fixed a by 2. Okay, this difference between, or distance between x and x prime is what? A by 2. So if x prime oscillates, or let's suppose this is the block, okay, and its length is equal to a by 2. What is the length? Its length is equal to a by 2. Okay, suppose this position is x, right? Or suppose this position is x. So what would be position of this one? Position of one end is x, suppose. Position of other end is suppose x prime, which is equal to x minus a by 2. At some point, suppose this end is at position x, this end is at position x prime. What's the difference between them? A by 2. And now this x prime changes. How does it change? It changes as minus a by 2 cos of 2 omega t. So this thing is simple harmonic motion, right? So x prime is changing that way, means simple harmonically. Okay, that means x will also change simple harmonically. Is this thing clear now? Okay, so then what's the frequency? Frequency is omega prime equals to 2 omega, and therefore what would be the time period? You can very easily find out the time period. Substitute what? Omega prime is 2 pi by t. Okay, so 2 pi by t is equal to 2 omega, 2 gets cancelled, and then you have time period is equal to what? Pi by omega. So this is a simple harmonic motion with a period of pi by omega, but you want frequency, no? So frequency would be omega by pi. Okay, so frequency would be omega by pi, right? So I thought there is time period in options, there is frequency, right? It is 2 pi n prime, let's say. So 2 gets cancelled. Okay, so frequency n prime would be just omega by pi. Very simple, right? Okay, so now since you are seeing this question for the first time, it might seem difficult, but now onwards, if you have a multiplied by sine square omega t or cos square omega t, so that one is what? It is also simple harmonic motion, but with the frequency twice that of omega, right? This thing is clear. Angular frequency would be twice that of omega. Okay, everyone, this is clear. All right, good. Let us see next one. A pendulum is hung from roof of sufficiently high building, and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of pendulum is 20 meter per second square at a distance of 5 meter from the mean position. The time period of oscillation is. Alright, a pendulum is hung from roof of sufficiently high building. Acceleration of the bob of pendulum is A is equal to 20 meters per second squared and x is equal to 5 meters. Then the time period of the oscillation is, this is the question, what would be the time period? So this is very simple, because we know that acceleration is what? Minus of omega square x. Okay, so let's take magnitude only. It would be omega square x. So that is 20 is equal to omega square multiplied by 5. So take 5 on other side. So omega square equals to 20 divided by 5. It's option B. Let's check. This is 4. So omega is equal to 2. And what do you want? You want time period. So that is 2 pi by t is equal to 2. 2 gets cancelled. Take t on this side. So t is equal to pi. Okay, good. So t is equal to pi seconds is the answer. Okay. So very simple question, right? All right, let's see next one. A particle executes simple harmonic oscillation with an amplitude A. The period of oscillation is t. The minimum time taken by the particle to travel half of the amplitude from the equilibrium position is. Equilibrium means mean position. Option B. Okay, let's check. Others, tell me. Minimum time required by the particle to travel distance equal to half of the amplitude. All right, this is simple. X is equal to, because it is starting from equilibrium position, our equation would be x is equal to a sine of omega t, right? And you want to travel distance equal to half of the amplitude. So it is a by 2 is equal to a sine of omega t. Then this a gets cancelled out. What do you have? Sine omega t. Sine omega t is equal to half, because a got cancelled out. And then you can write that omega t is 2 pi by capital T into t. But before that, since sine omega t is equal to half, omega t must be equal to what? 30 degrees, right? So 30 degrees is pi by 6. Okay, so omega is 2 pi by t. So 2 pi by t into t is equal to pi by 6. Pi and pi gets cancelled. Take this t on that side, 2 on that side. Okay, so you get t equals to t by 6 times 2 is t by 12. So this is the answer, right? Okay, very simple. Okay, good. Let's see next one. The circular motion of a particle with constant speed is periodic but not simple harmonic, simple harmonic but not periodic, periodic and simple harmonic, neither periodic nor simple harmonic. Tell me which one is correct. Periodic but not simple harmonic, right? Yeah, it's very clear. Circular motion is not simple harmonic, okay? Because in circular motion particle doesn't oscillate, okay, doesn't go to and fro, right? But there is a connection between uniform circular motion and simple harmonic motion. We'll see that. Okay, let us see next one. Average velocity of a particle executing SHM in one complete vibration is, tell me. Okay, very good. Everyone, in one complete oscillation, what would be the average velocity of particle? And this is from NEET 2019. So again, this is asked by NTA. Everyone, is option A correct? It is correct, no? Because particle starts from this position, suppose, and in one oscillation, it will come back to the same position. So no displacement. No displacement means average velocity is 0, right? Okay, good. All right, let's see next one. A particle executes linear simple harmonic motion with amplitude of 3 centimeters. When particle is at 2 centimeter from mean position, the magnitude of its velocity is equal to that of its acceleration. Okay, when it is at 2 centimeter, magnitude of velocity is equal to that of acceleration. Then the time period of in seconds is, then its time period in seconds is. This is the question. So again, this is also very simple, because they say that the magnitude of velocity is equal to acceleration. So acceleration and velocity is equal. So A is equal to V. What is the equation for acceleration? Omega square x. They are saying its magnitude, so we'll just write omega square x, no negative sign, and it's equal to omega square root of a square minus x square. Okay, then this omega and this one will get cancelled. Okay, then you need to take square of this thing, so omega square x square is equal to a square minus x square. Okay, and then what do you get? Substitute the values of x and a, right? Substitute values of x and a. So x is equal to 2, so this will be 4 omega square is equal to a is 3, so 9 minus 4. Okay, then this thing is 5, so omega square is equal to, you get 5 divided by 4, and therefore what will be omega? So omega is square root of 5 by 4, but omega is 2 pi by t, right? So omega is square root of 5 divided by 4, sorry, root of that is 2. So omega is 2 pi by t. 2 pi by t is root of 5 by 2. That means take t on that side. So t would be equal to 4 pi by root 5. That's the answer. 4 pi divided by root 5. It's option B. Okay, this one is clear. Yes, no. Okay, again very simple question. Right, let's see next one. A particle is executing a simple harmonic motion. Its maximum acceleration is alpha and maximum velocity is beta. Then time period of vibration will be, maximum acceleration is alpha. Okay, so what would be alpha? Alpha would be equal to omega square a. Maximum velocity is beta. What would be beta? Beta is omega times a by magnitude. Okay, then its time period of vibration would be, it's very simple. Let's take beta divided by alpha or alpha divided by beta. So this thing will get cancelled out. A gets cancelled out, right? And what remains is omega on this side. So omega is equal to alpha by beta. That means omega is 2 pi by t, which is equal to alpha divided by beta. And then move beta and alpha on other side, t on other side. So we get t is equal to 2 pi beta divided by alpha, right? So it is option B. Good. 2 pi beta divided by alpha. Okay, so this is very simple, right? Everyone? Okay, good. Let's see next one. A particle is executing SHM along a straight line. Its velocities at distances x1 and x2 from the mean position are v1 and v2 respectively. Its period is, what is this time period? This is the question. Okay, particle is executing SHM and its velocity is v1 at distance x1 and v2 at distance x2, and what is the time period? So again we can write down equations for v1 and v2. So v1 would be equal to what? Omega plus minus omega multiplied by square root of a square minus x square, but that would be x1 square because speed at x1 is equal to v1. And then if you look at the options, there is square everywhere, so we'll also square. Okay, so v1 square would be equal to omega square times a square minus x1 square, and I will write this thing as omega square a square minus omega square x1 square. Okay, similarly, is it option D? Okay, let's check. This is v1 square. Similarly, we'll have v2 square is equal to omega square a square minus omega square x2 square. And then now what we can do is, there is no a in the options, that means we need to get rid of a. Okay, so let's get rid of a. How can we do that? So we can either subtract the second equation from first equation or first from second. Okay, so if you look at the options, it is second minus first, sorry, first minus second. So subtract that, what do you get? Subtract second equation. So here on left hand side you will have v1 square minus v2 square, and that's equal to, this thing will get cancelled. Okay, you have minus omega square x1 square, and this will become minus minus plus, right? This term will be negative, this term would be positive. So it is omega square, and you can take omega square common, x2 square minus x1 square, right? Then what you can do is, you can write omega square equal to v1 square minus v2 square divided by, you have x2 square minus x1 square. Okay, and then take square root of that. right? So omega would be equal to root of that. Okay, take square root of that, it is this thing, and omega is 2 pi by t. 2 pi by t is square root of this thing, means t would be equal to, take t on this side and this root will go on that side, so that means the numerator and denominator will be flipped. Okay, so therefore t is equal to 2 pi multiplied by square root of x2 square minus x1 square divided by v1 square minus v2 square. Okay, so this is option D. This is the answer. A particle of mass m oscillates along x-axis according to the equation a sin omega t. X is equal to a sin omega t. The nature of graph between momentum and displacement of the particle is. Okay. So see, if it is oscillating particle, then the graph between momentum and displacement, or the velocity and displacement, would be an ellipse. Okay, that graph would be an ellipse. Okay, just remember this, the graph would be ellipse. I will explain it how, but it would be an ellipse. Alright, so let's see how. So see, we have x is equal to a sin of omega t. Okay, then what would be velocity? Velocity would be equal to a omega multiplied by cos of omega t, because velocity just v is dx by dt. So if you take derivative of sine is cos, but then you have omega in multiplication of t, so therefore that omega will come out, that means you need to multiply by omega. So you have v is equal to a omega cos of omega t by the chain rule, right? But then you want momentum, so therefore what is momentum? It is mass into velocity, and that is equal to m times a omega multiplied by cos of omega t. Okay, then see, what I can do here is, I have x is equal to a sin omega t, I have p is equal to m a omega cos of omega t. So what I can say is x by a is sin omega t, right? And then p divided by m a omega. So let's suppose this is some b. Okay, this is b. What is b? B is m a omega. So b times cos of omega t, where b is equal to what? M a omega, right? What is b? B is equal to m a omega. Okay, so then what do I have? So x by a is sin omega t, p by b is equal to cos omega t. Then if you square it and add it, what will happen? So you will have x square by a square plus p square by b square is equal to sin square omega t plus cos square omega t, and that is equal to 1, right? Sin square omega t plus cos square omega t, and that is equal to 1. So this is equation of an ellipse. Okay, what is equation of an ellipse? X square by a square plus y square by b square. Okay, because you are plotting position on x axis and momentum on y axis. Okay, so x square upon a square, equation of ellipse, is x square upon a square plus y square divided by b square is equal to 1. Okay, so this thing, so if you see this equation, it matches with equation of an ellipse, and therefore the answer would be ellipse. Okay, this thing is clear? Yes, no, everyone? Okay, so similarly, what I said is the graph between position and momentum, or position and velocity, would be what? It would be an ellipse. So see, you can write velocity also, v is equal to a omega cos omega t, And again, if you see here also, you can write cos of omega t is equal to what? It is equal to v divided by a omega. Okay, and this a omega can be written as b. So then you have x square by a square, okay, plus v square by this thing square would be equal to 1. Okay, that means graph between x and v is also an ellipse. Okay, so graph between x and v is an ellipse, graph between x and momentum is an ellipse for simple harmonic motion. Okay, so just remember it as a fact. Okay, so in simple harmonic motion, graph between the position and velocity is ellipse, graph between position and momentum is also an ellipse. Okay, all right, good. And in one case the graph would be a circle, so let me tell that. So in one case the graph would be a circle. So see, what is a circle? Circle is special kind of an ellipse. Okay, circle is a special kind of ellipse. See how? So equation for ellipse is x square by a square is equal to, x square by a square plus y square by b square is equal to 1 if a is equal to b, okay, and suppose it's equal to r. So what will you substitute for a and b? You will substitute r. Then what do you get? X square divided by r square plus y square divided by r square is equal to 1. You can move that r square on other side. What you get is x square plus y square is equal to r square. Okay, and this is equation of a circle. Okay, this is equation of a circle. Okay, so if omega is equal to 1, okay, if you take omega equals to 1, see omega is equal to 1, then what would be the equation between x and v? Then equation between x and v would be circle, otherwise it would be ellipse. Okay, the equation or the graph between, sorry, I said equation, graph between x and v is a circle, and if omega is equal to 1, m is also equal to 1, then the graph between x and p is also a circle, right? Because then here x square plus v square would be equal to a square, and here x square plus p square would be equal to a square. Okay, this thing is clear, everyone? In one case it would be a circle. Which case? So if you want graph between x and v to be a circle, then omega has to be equal to 1 radians per second, right? If you want graph between x and p to be a circle, then omega should be 1 as well as m should be 1, or actually product of m times omega should be 1. Okay, so it's not necessary that m and omega is 1. Okay, the product of m times omega should be equal to 1, right? This m times omega should be equal to 1. Okay, this thing is clear, everyone? Yes, no? Is there a doubt in this? Right? Selva Kumar?
No, sir.
Okay, good. So just remember these conditions. Okay, first of all, this is important because this has been repeated. Once they asked momentum, once they asked the graph between x and velocity. So this one has been repeated. Okay. All right, let's see next one. Two simple harmonic motions of angular frequency 100 and 1000 radians per second have same displacement amplitude ratio of their maximum acceleration is. So this is very simple, right? So omega 1, you have omega 1 equals to 100 and omega 2 equals to 1000. And what is A1 by A2? A1 max divided by A2 max. A1 max by A2 max. So it will be omega 1 square A1 divided by omega 2 square A2, right? This A1 and A2 is amplitude. This A1 and A2 is acceleration. And they say that maximum amplitude is equal. Okay, sorry, the displacement amplitude is equal. A1 is equal to A2. What is maximum amplitude? Amplitude is maximum displacement, right? Yeah, this thing is equal. So omega 1 by omega 2 square, that means this is 100, this is 1000, so that's 1 by 10. 1 by 10 square is 1 by 100. Good, so it is option D, correct. Okay, all right, this is simple. Let's see next one. A point performs simple harmonic oscillation of period t. An equation of motion is given by x is equal to a sine of omega t plus pi by 6. After elapse of what fraction of time period, the velocity of particle will be equal to half of its maximum velocity. Okay, velocity will be equal to half of the maximum velocity. So tell me. So given is x is equal to a sine of omega t plus pi by 6, right? So then what would be velocity? It is a omega cos of omega t plus pi by 6. Maximum velocity is a omega. So option B. Okay, let us check. Maximum velocity is a omega. So V is equal to what? A omega divided by 2. This is given. V is equal to maximum velocity divided by 2. V max by 2 means a omega divided by 2. So let us substitute that. V is a omega divided by 2, that is a omega multiplied by, you have cos of omega t plus pi by 6. So this a omega gets cancelled and you have half is equal to cos of this thing. So this thing must be equal to what? Omega t plus pi by 6 must be equal to, because its cos is half, means angle must be equal to what? 60 degrees, right? Because cos 60 is half, sin 30 is half, cos 60 is half. 60 means it is pi by 3. Okay, and this is because cos of omega t plus pi by 6 is equal to half. So this angle must be equal to 60 degrees, that is pi by 3. Then take that pi by 6 on other side. So you get omega t is equal to pi by 3 minus pi by 6. So that is pi by 6 only. Okay, and this thing is 2 pi, omega is 2 pi by capital T. So 2 pi t by t is pi by 6. Pi gets cancelled. So then you get t equals to, take t on that side, 2 on that side, so t by 12. That's correct. T is equal to t by 12. Okay, so it is option B. Right? This is clear? Okay, good. So how did you solve it, Banu? This way? Or something else? Yeah, that is correct. Okay. Time taken to reach half the amplitude is t by 12. Okay, that is correct, but it depends where does it start from. It's not like, see here, suppose particle started at the mean position. Okay, yeah, so suppose particle starts at mean position, then what would happen? So x is equal to, you have a sine of omega t, and then if they ask time for the velocity, okay, time when v is equal to v max by 2, then what would happen? We can proceed the same way. So v is equal to what? It is equal to a omega multiplied by cos of omega t, and this is v max by 2, that means a omega by 2. Okay, so this thing would be a omega by 2 is a omega times cos of omega t, then this thing will get cancelled out. Okay, so you get cos omega t equals to half, and that means omega t in this case would be equal to pi by 3. Okay, if omega t is pi by 3, that is 2 pi t by t is pi by 3. Okay, and then you can find pi will get cancelled, so t would be equal to what? T by 6, not t by 12, right? So that will not hold true every time. Okay, all right, good, because you told it very fast, so I had a doubt. Anyways, so you need to solve it. Okay, because they can alter the positions and they can alter the question also. So sometimes they can ask at what position, at what time the position will become half of the amplitude. Okay, at what time the velocity will become half of the amplitude. So it will be different depending upon starting position, right? Okay, this is clear, everyone? All right, good. Okay, so let's see next one. The phase difference between the instantaneous velocity and acceleration of particle executing simple harmonic motion is, we know it is pi by 2, right? So it's option D. So see, this one is repeated many times. Okay, phase difference between this and that. Let's see next one. Particle executing simple harmonic motion of amplitude 5 cm has maximum speed of this much. The frequency of oscillations is. So again, this is very simple. Okay, so V is equal to, you have a omega, this is maximum speed, no? So then we can substitute values. Okay, so V is 31.4 is equal to, now I guess it is good to substitute omega here, which is 2 pi n. Okay, so it would be a multiplied by 2 pi times n, this is V. Okay, and we want n, so let's substitute values. This is 31.4, amplitude is 5 times 2 is 10, 10 times you have 3.14, and that all gets nicely cancelled out. This is 10. Okay, this is 31.4, yeah, this thing gets cancelled out, so you have n is equal to 1. Good. So very simple question. Okay, all right, let's see next one. Which one of the following statements is true for speed v and acceleration a of the particle executing simple harmonic motion? Tell me which one is correct. Yes, when v is maximum, a is maximum, value of a is 0, whatever may be value of v. When v is 0, a is 0. When v is maximum, a is 0. Which one is correct? Option D. When v is maximum, a is 0. That is correct. So that's correct. When velocity is maximum, you say, you are saying option A, when V is maximum, A is maximum. No, no. See, where is the acceleration maximum? Where the force is maximum, right? So when you stretch the spring at extreme position, right, at extreme position the force would be maximum. Okay, plus or minus A, no problem. Okay, so at extreme position the acceleration is maximum, but there the velocity is equal to 0. Velocity is 0. Okay, so this is incorrect. But velocity is maximum at the mean position and acceleration is 0. Okay, so this one is very simple. All right, let's see next one. A particle of mass m is released from rest and follows a parabolic path as shown. Then, assuming that the displacement of mass from the origin is small, which graph correctly depicts the position of particle as function of time? Tell me. If mass is released from here, it will oscillate like this. Okay, it will oscillate like this. So which graph represents its position versus time? Tell me. Is it option A? Everyone? Right? It is option A, because at beginning x is maximum. Okay, it is released from here. That means the amplitude cannot be greater than that. Okay, then the position will go on. Okay, it will move towards the mean position, right? And then it will move away from mean position on the other side. That means it starts from this position, then it goes to the mean, then it will go towards other end, then it will come back, so on and so forth. So it is option A. Okay, why not option C? Because this motion would be a simple harmonic motion. Okay, this motion would be what? Simple harmonic motion. So it follows sine or cosine curve. Okay, it is not a triangular wave. Option D? No, it can't be option D. No, object is released from here. Object is released from extreme position. Okay, mass is released from there. Right. So it is released from extreme position, then it will come back to the mean, then it will go to the other end, right? Because it will gain some velocity while coming to this point. After that, it will keep on moving. Okay, because it has attained some velocity. No, no, no. See, it starts from rest. Okay. See, it starts from rest from here, but because of the gravity, what will happen? It will move like this. It will attain some velocity. It starts from rest, that is correct. So V is 0. Okay, at time t equal to 0. But where does it start from? Now you need to understand, after let's say 1 second, where will it go? Or will it go anywhere at all? Okay, it will attain some speed, no? It is released from here. Because of gravity, it will attain some speed. Yes, no?